Hello everyone, my name is Anand Suthar and welcome back to my LeetCode Problem solving series. Today we are solving validate binary search tree LeetCode Problem number 98. This is fundamental tree problem that tests your understanding of BST properties. There is a simple solutions using Inorder Traversal. Let me show you what I mean. Here is the problem. We are given a binary tree and we need to check if it's valid binary search tree. What make a tree a valid BST? Three simple rules. First, the left subtree of a node contains only the nodes with a values less than the node value. Second, the right subtree contains only the nodes with the values greater than the node value. Third, both the left and the right subtree must also be binary search tree. Let me show you some example. In example 1, it's valid BST because it satisfies all the requirements of BST. And example 2 is invalid BST and its output is false because 3 is the right subtree of a 5 but 3 is the less than 5 that break the BST rules. Now there is a multiple way to solve this but I want to show you the most beginner friendly approach using Inorder Traversal. Before we look at the code, let me explain what Inorder Traversal is. In Inorder Traversal, we visit nodes in this order: left, then root, then right. For BSF, here is the magic. Inorder traverses gives the value in the sorted order. Let me show you why. BST. Let me trace through Inorder traversal step by step. We start at the root node 5. First we go to the left child 3. From 3 we go to its left child 1. Node 1 has no left child. So we visit 1 and 1 to other array. Then we go back to the 3, visit node 3 and 3 to the our array. Then we go to the right child of a 3 which is 4, visit node 4 and the 4 to our array. Then we go back to the root node 5, visit the node 5, add 5 to our array. Then we go back to the right child 7, from 7 check left child none. Visit node 7 and add 7 to our array. Then go to the right child 7 which is 9, visit node 9, add 9 to our array. Final array is 1, 3, 4, 5, 7, 9, completely sorted. This is the key insert. If the tree is valid BST, Inorder traversals will always give us a strictly increasing sequence. If the tree is invalid, we see the numbers out of order. So our solution become very simple. Do an Inorder traversals, collect all values, then check if they are sorted. Now let me write the code line by line. We start inside our public function is valid BST. The first thing we do is declare an empty vector of integers called values. This vector is going to act as our shopping basket where we will store the tree numbers as the visited them. So we call our private helper functions named in order. We pass it the root of our tree and our value basket. This function will crawl through our entire tree and fill our vector with a number using left, root, right in order pathing. Once the in order function finishes, our vector is filled. Now we run a simple for loop from index 1 and the way to the end of the vector. Inside the loop, we compare our the current number values I with the number right before it, values I minus 1. If our current number is less than or equal to the previous number, our strictly increasing rule is broken. This means the tree is not valid BST, so we instantly return false. If the loop finishes checking every nearby pairs and never flag a violation, it means our number is perfectly sorted. The tree is valid BST, so we drop the bottom and the return true. Now let's step into our private helper function to see exactly how it populates the vector. We name this function in order. It return void because its only the job is fill our vector, not compute the final true or false answer. The very first line is our safety check. If the current root is null, it means we have hit an empty spot past of the leaf node. We simply return and stop going deeper down this dead end. Following the in-order rules, we checking the left side. First, we recursively check the in-order on the root left. Once the left finishes, if we visit the root node itself, we take a current node's value and drop it into the values vector using pushback. Finally, we visit the right side by recursively calling in orders on root right, and that is entire process, left then root then right. Its time complexity will be O(n). We visit each node exactly once during in-order traversals. Its space complexity will be O(n). We store all the n nodes values in vector plus the recursion stack for the in-order traversal. Let me submit this and it passes. That is the validate binary search tree using in-order traversals. The key takeaway: in-order traversals of a BST gives the sorted array. If you found this helpful, please like and subscribe. I am Anand. Thanks for watching. I'll see you in the next problem.